All right, in this video, we're going to do some examples of determining whether two triangles on the coordinate plane are congruent or similar or similar with one another. So here's our first example. We have triangle ABC and we have triangle DEF. Triangle ABC has vertices at A, B, and C, and triangle DEF has vertices at D, E, and F, as given in these coordinates here. And so the three sides of the first triangle are A to B, then B to C, and then A to C. So we have we got to get the measure of side segment AB, which is one of the sides, then the measure of side BC, and then the measure of side AC, and then we'll do DE, then EF, and DF. And we're going to use the distance formula, and I am going to shortcut these calculations, just in case you're not sure what I mean by that. I'm not going to do the full distance formula. What I'm going to do is when I do between A and B, I'm just going to say, well, 1x is 2 and 1x is 5. What's the distance between them? Well, 5 minus 2 is 3, so I'm just going to do, 3 squared in my distance formula, okay? All right, so the measure of AB, the distance formula will be the square root of, and my two x's are 2 and 5. Well, what's the distance between 2 and 5? It's 3, because 5 minus 2 is 3. So we're going to do 3 squared plus, then the y coordinates are 1 and 8. Well, how far is it between 1 and 8? Well, 8 minus 1 is 7, so that's 7 squared. And so that's going to be the square root. 3 squared is 9. 7 squared is 49. And so that distance is the square root of 58. Now I'm going to leave it as a square root. I'm going to leave it as a radical. Why? Well, because all of these are going to be radicals. So then we can just ignore the radical and just compare what's under the radical. Okay. All right, now let's do BC. So B and C. So the distance from B to C is going to be the square root of, well, the x coordinates are 5 and 11. How far is it from 5 to 11? Well, 11 minus 5 is 6. So we're going to say 6 squared plus. Then the y coordinates are 8 and 3. How far is it between 8 and 3? It's 5, because 8 minus 3 is 5, so 5 squared. So it's going to be the square root. 6 squared is 36. 5 squared is 25. And so 36 plus 25 is, 61. So 61. And so we have the square root of 61. So you can see BC is a longer side than AB, because BC is the square root of 61, where AB is the square root of 58. Okay. So now let's do the length of AC. A is at 2, 1. C is 11, 3. So we're going to do the square root of, our x's are 2 and 11. 11 minus 2 is 9, so we're going to do 9 squared plus. Our y values are 1 and 3 minus 1 is 2, so that's 2 squared. So we're going to have the square root of 9 squared, that's 81, plus 2 squared is 4. 81 plus 4 is 85, so we're going to have the square root of 85. Okay, so square root of 85. So it looks like the longest side is AC. The middle side is BC, and the shortest side is AB. Now we're going to do the same thing for triangle DEF. All right, so let's calculate the measure of side DE. So we're going from D, 3, negative 10, to E, negative 4, negative 7. All right, so distance, square root of, well, what's the distance between 3 and negative 4? Okay, well, that's 7. So we're going to do 7 squared. You may say, how did you know the distance between 3 and negative 4? Well, 3 is 3 units away from 0, and negative 4 is 4 units away from 0. And so we can just add those together. 3 plus 4, absolute value of 4 is 7, because they're both on the other different sides of 0. Another way you could do it is 3 minus negative 4. Well, 3 minus negative 4 is the same thing as 3 plus 4. Okay, So be careful with that. You should know the number line. You really need to know the number line. You know, if we had the number line, 3 is on one side of 0, negative 4 is on the other side of 0, and that's how I know that they're 7 units away. Okay. All right, so plus, how far is negative 10 from negative 7? Now, they're on the same side of the number line, and if they're on the same side of, if they're on the same side of 0 on the number line, then we can just do 10 minus 7, which is 3. Or we can say, well, starting at negative 7, we can go to negative 8, then negative 9, then negative 10. So 1 unit away from here, 2 units away from here, 3 units away from here. Okay, so negative 7 and negative 10 are 3 units away, so that's 3 squared. So that's going to be the square root of. 7 squared is 49, plus 3 squared, that's 9. 49 plus 9 is 58, so square root of 58. Okay, so DE is the square root of 58. Now that's good news because we see square root of 58 up here in AB, so we might have congruent triangles here. All right, now let's do D to E. Here's D and here's E. How far is 3? We just did DE. I'm sorry, we're doing EF. So E to F. How far is negative 4 from 1? So negative 4 and 1 are 5 units apart. So that's the square root of 5 squared plus, and then how far is negative 7 from negative 1? Those are 6 units apart, so we'll do 6 squared. So that's the square root of 5 squared is 25, plus 6 squared is 36. 25 plus 36 is 61, so we got the square root of 61. Yeah, it looks like this is going to work out. We got the square root of 61 here, but it's possible for this last side to not be the square root of 85, so let's just check this out. So our third distance is going to be from D to F. So how far is it from 3 to 1? 2 units away, so that's the square root of 2 squared plus, how far is negative 10 from negative 1? Those are 9 units apart, so that's 9 squared. So we got the square root of 2 squared is 4 plus 9 squared is 81, and 4 plus 81 is 85, so that's the square root of 85. Yep, we have 3 congruent, we have 3 congruent sides. So our longest side on DEF is square root of 85, our middle side is square root of 61, and our shortest side is square root of 58. And so the shortest sides on both triangles are equal, both are square root of 58. The middle sides are equal, measure square root of 61, and the longest sides are equal, measure square root of 85. So the question is, are these triangles congruent? The answer is yes. Triangle ABC is congruent to triangle DEF by the side-side theorem. Okay? All right, now the question is, are they similar? Well, the answer is yes. If 2 triangles are congruent, they are automatically similar. So the answer to this is yes. But I want to show you why, just in case you're wondering, why are congruent triangles always similar? Okay? And it's going to be a really easy thing to show you. So remember, to find out whether they're similar, we're going to put the largest measure from one triangle, square root of 85, over the longest measure from the other triangle, square root of 85. So here's the proportion of our sides. Well, square root of 85 divided by square root of 85 is 1. Then we're going to do the middle sides. Square root of 61 over square root of 61. Well, that's also equal to 1. Okay? And then square root of 58 over square root of 58 is also 1. And since the proportion of all the sides is the same number, 1, that means that these 2 triangles are similar. Okay? Let's try another example. All right, now let's look at, let's see these triangles. We have triangle GHJ and triangle KLM. GHJ has these vertices on the coordinate plane. KLM has these vertices on the coordinate plane. If you're not sure how to identify what the sides are going to be, it's always going to be the first and second letter, then the second and third letter, and then the first and the third letter. Okay, so we're going to have side GH, side HJ, and then side GJ. Okay, then we're going to have side KL, then side LM, then side KM. Okay, side GH here is going to be between 4, 6 and 11, 3. Okay, so let's use the distance formula. Again, I'm going to do the kind of the shortcut. What's the distance between 4 and 11? Well, 11 minus 4 is 7, so we're going to have 7 squared plus. And then what's the distance between 6 and 3? Well, that's 3. So 3 squared. There we go. So we're going to have the square root. Well, 7 squared is 49, and 3 squared is 9. So that's 49 plus 9. So we got the square root of 58. And so GH is square root of 58. Now let's find the distance between H and J. We're going from 11, 3 to 1, 4. Well, how far is it between 11 and 1? Those are our x values. 11 minus 1 is 10. So the square root we'll do 10 squared plus. Then how far is it from 3 to 4? Well, it's 1. 1 unit from 3 to 4, so that's 1 squared. So we're going to have the square root. 10 squared is 100. 1 squared is 1. And so this is going to be the square root of 101. So side HJ, the length of side HJ is the square root of 101. Now let's do the distance of side GJ. So we're going from 4, 6 up to over to 1, 4. So our x's are 4 and 1. How far is it from 4 to 1? 3. So we'll put 3 squared plus. How far is it from 6 to 4? 2. So we'll do 2 squared. And so that's going to be the square root of, well, 3 squared is 9 plus 2 squared is 4. And so we're going to have the square root of 13. Okay, so GJ is the square root of 13. Now let's go to the other triangle. We're going to do KL. All right, so K is at 0, negative 10. L is at negative 2 and positive 10. So the distance there is going to be the square root of, well, how far is it from 0 to negative 2? Well, it's 2 units away, so that's 2 squared plus. How far is it from negative 10 up to 10? Okay, that's a long distance. Negative 10 to 0 is 10, and then 0 up to 10 is another 10, so that's 20 units. So that's 20 squared, and so that's going to be the square root of 2 squared is 4 plus, what's 20 squared? Well, you may need a calculator for that, but I can tell you that 20 squared is 400. All right, so that's going to give us the square root of 404. So square root of 404. I also want to point out here, I didn't go back and say which one was the shortest side and which one was the longest side. You can see here that square root of 101, that's our longest side. Square root of 13, that's our shortest side. And in the middle there is square root of 58, so we'll mark that. Let's see what LM is here, the distance of LM. We're going from negative 210 to negative 6, 4. So how far is it from negative 2 to negative 6? Well, that's 4 units away. So we'll do 4 squared plus. How far is it from 10 to 4? Well, that's only 6 units away, so that's 6 squared. So we'll do the square root of 4 squared is 16 plus 6 squared is 36. And 16 plus 36 is 52. So we've got the square root of 52 here. So we'll do the square root of 52. Last one, we'll do the length of KM. So distance equals, we're going from 0, negative 10 to negative 6 and 4. Well, how far is it from 0 to negative 6? That's 6 units away. So we'll do the square root of 6 squared plus, and then how far is it from negative 10 to positive 4? Okay, that's 14 units away. And you can check it out on a number line if you want to. It's 14 units away, so 14 squared. So now we're going to have the square root of 6 squared, that's 36, plus 14 squared. If you don't know that one by heart, you might want to get used to it. That's 196. And so square root. 36 plus 196 is going to be 232. So we're going to have the square root of 232. Square root 232. The largest of these numbers is square root of 404, so that's our longest. The smallest one is square root of 52, so that's going to be our shortest side. And then in between them is square root of 232, that's our middle side, okay? All right, so are these triangles congruent? Absolutely not. Look, the longest side in GHJ is square root of 101. The longest side in KLM is square root of 404. And so they are clearly not congruent to each other. So we would say that triangle GHJ is, we can write congruent and then put a slash through it, not congruent to triangle KLM. Okay? All right, well, let's now check to see if they're similar. All right, to find out if they're similar, what we have to do is we have to put the this is the larger triangle. It has its largest side is the square root of 404, and that's bigger than square root of 101. So for the bigger triangle, we're going to take the larger side, square root of 404, square root 404, and we're going to put that in the numerator. In the denominator, we're going to take the longest side from the smaller triangle, which is the square root of 101. And we're going to go calculate that in the NumWorks calculator. All right, here's the NumWorks calculator. We're going to go into the calculation, and we're going to do the square root of 404. Let's get out of the radical. Then we'll hit divided by, and then we'll do the square root of 101, and the answer is 2. All right, so let's go back here. We'll say square root of 404 divided by the square root of 101 is 2. All right, so now let's do the middle sides. We'll do the square root of 232, square root of 232, divided by the square root of 58. Square root of 58. Let's go back to the NumWorks calculator here. Let's see, what is it? 232 and 58. So square root of 232 will come out of the radical, divided by square root of 58. And sure enough, we get 2 again. That's good news. All right, we might be similar. Let's see what we got on this other one. We'll take the larger triangle, smallest side, square root of 52 over the square root of 13. Square root of 52 over the square root of 13. Calculator. So go to the square root of 52, come out of the radical, hit divided by square root of 13, and sure enough, 2. So this is going to be 2, and since the proportion of the side lengths is the same for small, medium, and large, then we can say that they are similar. So we can say that triangle GHJ is indeed similar to triangle KLM, even though they are not congruent triangles. So they're not congruent, but they are similar. Okay, I think that's it for this video. I'm going to do another video with a couple more examples.